This is logarithmic differentiation. It is on neither the AB nor the BC exam. That doesn't mean it shouldn't be taught. It doesn't mean you shouldn't learn it. But I'll also tell you, if you listen carefully, Ryan, that possibly there's a bonus question related to this section. So it might be worth your while to do these problems. I think there's like all of one, but we'll see why we want to do this. It's just a math trick. Okay, you guys? Okay, Ricardo? It's a math trick. I want to find the derivative of that ugly-looking function. Looks complicated. And I could do it. I could do the quotient rule combined with the chain rule, and then I have to simplify, and that can be hard. So what I'm going to do instead is I'm going to do a math trick and make it an easier problem. I'm going to log both sides because I know this. What is the log of A divided by B? Log of A minus the log of B. And that's easier to differentiate. So in your homework, there were problems like that as well. So you need to practice with it because you won't remember to do that. It's easier if you have a logarithm to simplify it and then take the derivative. There's also this one, the log of x to the r, which is what? R times the log of x. Now I do just say log. It's always natural log. If it's something other than that, I'll say base something, because everything's going to be pretty much natural logs. So I'm going to take the natural log of both sides, and I'm going to get the natural log of y is equal to the natural log of that quotient. But can I rewrite that easier? Sure, I can take the natural log of the numerator and subtract from it the natural log of the denominator. And we can make this simpler even more so. Now all I've done is log both sides. I haven't taken any derivatives. Can we still simplify that with logs? What can you do with the 5? Bring it down. So this is equal to 5 times the natural log of 3x squared minus 4. And then I can bring this 3 down. So minus 3, natural log of negative 2x minus 5. Can we distribute the logs? I wish, but we can't. Nope. You can take the derivative. It's as simple as I can get it. So let's take the derivative of both sides. Now, this is going to be done implicitly. This is the explicit equation right there, this thing. This is now implicit. So I'm trying to justify another reason for doing implicit differentiation, because sometimes it's just easier. Okay, so what's the derivative of the natural log of y? 1 over y times, chain rule, the derivative of the inside function. So it's dy dx equals. Now I can just ignore the 5 and take the derivative of the inside function. Well, that's what? What's the derivative of this? You just did a worksheet on it. It's 1 over the function, 3x squared minus 4, and then you have to do the derivative of the inside function, times 6x. So it's 1 over the function, which is 3x squared minus 4, times the derivative of what's inside. Yes? I could, using the product rule, but what's the derivative of 5? It's 0. So I can always take a 5 through a derivative operator, a constant through that, which makes life easy. So I could do the derivative of this 3, but its derivative is 0. So, which will make that term 0, not everything, because they still have to do the derivative of this one. I'm going to multiply it. 3, and now I'm going to do the derivative of this one, so it's 1 over this function, 1 over negative 2x minus 5, times the derivative of the inside function, which is negative 2. And now all you have to do is solve for dy dx. Nope. The derivative of negative 2x is just negative 2. This isn't the power. This is a logarithm. What's the 1? What's the exponent? It's 1 times negative 2, and then it's x to the 0. You can. But I don't want 1 over y dy dx. I want just dy dx. What do I have to do to both sides? Multiply by?
By the y.
Okay. Should you put y back in? Yes. And guess what? I have already cheated a little bit, and there's the y. Remember, this was y. Remember what y was?
Did the R stick in there?
This is the y. What r?
No.
Can we plug in the y for every time?
What is that? The R next to the negative 2x minus 5
It's not an r, it's right up.
I don't see any r.
Right,
That's a 3.
Down, down, left.
Oh, that's just a copy error. That's no big deal. Okay, so what's y equal to?
I did actually.
dy dx, I'm sorry, is equal to this thing, and we don't have to simplify it, but we will. So 5 times 6x is 30x. Just multiplying fractions, 3x squared minus 4. And then I do minus 3 times minus 2, so it's plus 6. Once I factor out that negative there. Okay, times y. That's y. Yes. That's it. It's not too bad. Now I don't need logarithmic differentiation for this particular problem. They could, well, they won't ask on the exam. I've asked about it. It's not an exam. And neither is this problem, but I do, oh, I'm sorry. You look at the bottom of the page, those of you who are ready, you have x to the x. No, it's not a power, is it? No, we'll talk about powers. So it's 1 over the derivative of this. It's 1 over the derivative of that. You have the chain rule. Are we ready? Okay. Y equals x to the x. It's a crazy looking function. Okay, you guys, is that a power? A power would look like x squared or x cubed. I have variables in both places here. What would an exponential look like? 2 to the x. I still have a constant in one of the places. I have variables in both. So guess what? This is neither. And you can't use any of the rules I've given you. So the only way to do this, at least that I know of, is to do logarithmic differentiation. Actually, there's another way you could write it as e to the ln of something. It's neither a power nor an exponential. We can still find y prime. Let's take the log of both sides and see what happens. It's a trick. Remember, this is a trick. Sure, it's an operator. Just like a derivative is an operator. Okay, ready? So I get the natural log of y. Now what am I going to do with this exponent? X times the natural log of x. Now I highly recommend you put the dot in there when it's multiplied because sometimes you'll miss the product rule. Now let's take the derivative. And some of the homework problems, look like this. How do you do the derivative of x times log of x? So you need to practice. What's the derivative of log of y? 1 over y times dy dx. Is that okay, Grant?
Yeah.
Cole, is that okay? Now, what are you going to do here? You're going to take the first one times the derivative of the second, which is 1 over x plus the second, you should be doing this with me, times the derivative of the first, times 1. We're almost done. What do you have? Pardon? Yes, this will give us 1. What do you have to do to solve for dy dx? Multiply by both sides by y. So that the answer is dy dx equals, well, that's 1, right? Plus the natural log of x. What was y? Do you remember? It was x to the x. You have to recognize when you have an exponential and when you have a power. That's the answer. It's kind of a weird answer, isn't it? I was just thinking there is another way to do it, but you still have to use logs. Well, that's what it is. There's nothing you can do with it. Just leave it. No, this is not on the AP exam, neither AB nor BC, but it might be a bonus question on your test. Yes. What happens when you multiply these? That's 1. So the rest of the time is for you to work. Now, you guys, I know you have a lot of homework and stuff, so please use your time wisely. And I'm here to answer questions. I'm here in the morning as well.